Okay, so I'm Sverre, and this is my brother Trond. and together we have founded Røst. So today we're pleased to give you an insight into our product development journey. So one of the questions we quite often get is why do we make a sample roaster? And given our previous experience in oil and gas and finance, that's not such a strange question to ask. So our venture started almost 7 years ago when I was a student with a strong interest in coffee. And I couldn't find a high quality coffee for a price I could afford. And being a poor mechanical engineering student, I decided therefore to make my own coffee roaster. I completed what was to become my first coffee roaster in 2012. It was an electrical 1 kilo roaster. At the time I was fixated on the mechanical and technical challenges for making a coffee roaster. However, when I did my first roast, I realized that I've never roasted coffee before. So it was a steep learning curve, but the machine was able to roast coffee, although controlling it was a bit more of a challenge. Overall, I had so much fun working and developing this whole machine, and I was fortunate to convince my mentor at NTNU that this is what I wanted to write my master's thesis on. So on my master's thesis, I focused on making the machine more energy efficient, which I succeeded in. However, this made the machine even worse to control. So during my master's thesis, I was in regular email correspondence with Tim. I politely asked him plenty of coffee about questions about coffee, roasting, and roasting preferences. At the same time, Trond had bought a Quest M3, and to my amusement was struggling with the same challenges of controlling the machine. So we were discovering here a great business opportunity, we thought. So we decided to further develop the results of my master's thesis into a 1 kilo home roaster that was supposed to be easy to control and fun to roast with. So one of the first steps was to give Tim and Morten a demonstration. And the demonstration itself wasn't much to talk about, but during this session we were introduced into the idea of making a better sample roaster. And I was intrigued by this right from the start, especially since working with a 1 kilo capacity on electrical roaster, that you have some challenges with the amount of power you can draw from the electrical currents. So when you have the opportunity of roasting 100 grams on the same sort of energy capacity, it gives you a lot more flexibility when it comes to the design of the drum, the heat source, but it also, the low mass of coffee gives you challenges when it comes to reading the bean temperature, as well as controlling the external influences on the roasting process. So 6 months after the demonstrations with Tim and Morten, I had the first concept ready, and Trond applied for a grant from Innovation Norway. So shortly after, the first prototype was produced. This was intended to be an electrical roaster with the 2 heat sources, a primary heat source through convection and a smaller secondary heat source through conduction. But after a few tests, we had a few weeks of testing, and what we found out was that the small heat source didn't really help us much. The conductive part of it seems to be just lagging behind so much, and what it was basically doing was shortening down our preheating time. So after a few weeks of testing and countless heating elements, we had enough of the primary heat source as well. Since we want the main heat source to be convection, the electrical heating element first has to heat up the coils, then the coils heats up the surroundings, and with that the air that you want to roast the coffee with. So this works fine if you have a high airflow. to prevent the coils from heating up, you have to have a certain airflow going through the heating elements. And we didn't want to constrain the use of, we didn't want to constrain the airflow volume fixed on what is optimum for the heating element. We wanted to constrain it based on what's good for the coffee. So after that, we changed to gas. For our philosophy has always been to provide the tools for roasting and not to lay the guidelines of how to roast. So this is from our first workshop or demonstration with Morten at Nordic Approach. Fun fact about this roaster, and this is the prototype one, is that we're using a medicine box from IKEA to store both the electronics and to cool down the coffee beans in. So it's not the safest way of doing it. But this was a 100% manual roaster. You can hardly see it, but we're using a propane burner down on the left in the image to heat the source, which is, in order to channel the flame into the roasting chamber, we're using a pineapple box. But we did, during this roast, we did about, or this session, we did about 10 batches. And then Nordic roasted 4 batches on their Pro Bag. And there was the same coffee, of course. And at this point, we have had maybe 2 months of sample roasting experiences. But during the session, Morten gave us a lot of valuable insights and also instructions during the demo. So 3 days later, we did our first cupping with Morten, our first professional cupping. Well, this was a blind cupping. And among the 3 winners, 2 of them were ours. So that's not bad for our first cupping with our very first prototype. So we spent 2 years refining the design. The concept of having a fixed drum with mechanical agitation of the coffee beans while the heat is applied across, like diagonally across the roasting chamber, as opposed to the more traditional way of having the airflow going axial through the roasting, is still the same concept that we are using today, which I figured out 4 or 5 years ago. We just needed to make a lot of adjustments to make it function. Heat and stainless steel are not always the best of friends. When you have a construction that works in room temperatures and you heat it up to approximately 300 degrees Celsius, it might not work anymore. So this is a photo of our second prototype. And this is hopefully a short video demonstrating how it works. So that's the gas burner. And you see there you can't really see it, but there are 2 different drums there. And we have mechanical agitation, as you can see in the middle of the coffee beans. And already then we had live view, but it was still quite challenging to control this machine. But one of the biggest challenges was actually to get the coffee beans out. Sometimes it worked, and sometimes they didn't. I'm sure we were pretty pleased with the result of that roasting back then. I don't think we would have been as pleased today. So this is from our demonstration of our third roaster. This is at the factory in Denmark with Jens and Michael, where we had almost a full day of roasting with them. And this was the first roaster that could follow a predefined temperature curve. And it was also, this day was also the first time we tried to replicate the roast profiles of a large-scale roaster. It's not very easy to see, but on the 3 first prototypes, we have a system with double drums. So you rotate one of them to align different holes, and that is how you get the coffee out of the machine. So it got better on each prototype, but there were still always some issues with it. When it worked, but not always. So after discarding the double drum, we wanted to test out a new way of making the internal drum of the machine, and this is our first test concept. Here we used a Hoover vacuum motor to discharge the coffee beans and cool them, and that had a pretty impressive cool down time in a matter of seconds. But unfortunately, it did sound like the machine was about to lift off every time you used it. It did manage to smile every time, but the most important thing was that the drum worked, and the concept of how we're applying heat worked. So basically it's an improved version of this that we are using today. So when we started, it was more or less a hobby for us, where we spent evenings and weekends on it. But we always had a long-term goal of making this into something that we could do for a living, and to produce the world's finest sample roaster. To achieve this, it was important to get feedback from the coffee community and also understanding what our potential customer wants from a sample roaster. We therefore travel around with all of our sample roasters and prototypes, giving demonstrations and receiving feedback. And with every new prototype, we were always looking forward to finally having this prototype that looked really nice and everything was like neat. But the thing is with prototypes, they are prototypes. They never work 100%. So there's always something you have to modify and always something you're learning in the process. So that means you have to change something. So the result is that at best you got some interesting looking machines. So I'm sure most of them gave demonstrations to, thought we were a bit crazy dragging these prototypes around, giving demonstrations of something that barely fit together. But for us, it gave us valuable insight. And with our fifth prototype, we landed on a substantially better design. And we have solved most of our biggest mechanical challenges. This was also the first time we made a custom electronics for our machine. And it was time for us to go all in, and I started working full time from this point on. We secured financing for further developments and showed a prototype to 5 potential customers, whereof 4 of them are now our pilot customers, helping us improve the machine until we are ready for launch. So summarize, this is pretty much our story from prototype 1 up until prototype number 6. And right now we have prototype 7 in production. All of them are produced here in Norway, and we want to keep it like that. So what is like our concept? Well, Røst is designed for effortless operations. Our design philosophy is to make a sample roaster without any compromise, which is quite a big challenge. But we also want the machine to look nice and have specifications to impress. So far, I would say we are on the right track, but we still have some obstacles to overcome. I mean, who would have guessed that combining sensitive sensors, a 22,000 volt igniter, a gas burner, a touchscreen inside a wooden box will give you any troubles. Let's see if I can make this work. So this is our prototype number 6. So sample roasting is often all about just getting the samples roasted. So we are focused on making the workflow of the machine as simple as possible and making the machine automatic while maintaining the tools you need for interaction with the coffee bean. So you still have a window where you can like see the colors, you still have a dryer, So you still have this mechanical feel of it. And also all the sensors that you use are like connected, or the operators you use are connected to sensors, so you don't have to worry about did live you start, did this and that start. So it can be as simple as simply turn on the machine and add the coffee. All the data and everything is gathered through Wi-Fi, so it's stored in the cloud, so you can see it later, or you can have live view, you can design profiles, etc. So the machine can be controlled in 4 different ways. So you have you can roast based on a predefined temperature curve. And this temperature curve can be the environmental temperature in the roasting chamber, or it can be the bean temperature. You can also, or during any roast, you can always take full manual control. So you can take over and you can adjust the temperature directly, you can adjust the airflow, you can adjust the gas flow. So we ended up with a dual ventilation system. So the ventilation system is separated from the roasting chamber and the bean cooler. And this is to optimize back-to-back roasting capacity. And you can also play around in making profiles for the cool down period. Unlike traditional sample roasters, where you can buy like one system that have up to 6 barrels in one, we have a module-based architecture. So you start with one machine. If you need more, you can simply just add the capacity you need, and you can put them next to each other without interrupting the workflow of the system. That means that all the interaction with the coffee machine or the sample roaster is from the front. There's no need to have access to the side panels or the back. This means that you can place them right next to each other in a line. And also the shaft separator is also built into the system and is accessible from the front. So in order to do this, we have spent a lot of time on simply trying to make sure that you have access to everything from the front, which seems maybe simple, but it has actually created quite a lot of challenges in cramming everything up to the front of the machine, especially with a touchscreen that is 1.5 centimeter away from a flame that burns at 1,900 degrees. So we can take a look at some roast profiles. I'm trying to make the picture a bit bigger if it was a bit, but it doesn't matter. I have some. So this is a Colombian coffee that we roasted. So what we see in here is a manual roast, meaning that I had a fixed value of the gas and the fan setting. As you can see by the black line indicating the gas, right now it's indicating that it was at full power, that it's not. I just adjusted down the maximum value for this session. And you can see the airflow is fixed at 50%, that's the gray line. The other 2 lines you see is the blue one, which is the environmental temperature that you can roast based on, and the bean temperature, which you can also roast based on. And then you have a green reference point, which is at this point the profile that it used. If I hadn't taken manual control, it would have followed the green line as you see at the top. So at this one, it was the average time to first crack was 7 minutes and 23 seconds, with a deviation of plus minus 5 seconds. And at the time of first crack, the temperature of the beans were 185.4 degrees Celsius, with a deviation of plus minus 0.4 degrees. So this is the first, second, up until the 4th roast. And only had a 10-minute preheating stage before this. We also did a cupping with this coffee, where 3 of them were very similar. One of them was a bit off, but we didn't. I'm not 100% sure why. So there's still a bit of work to be done. But we also measure it with a colorette to see how fine they are. But I'm having some troubles with the colorette because it gives me different value every time I'm measuring it. So based on what I could find from there, it was plus minus 5 digits, for plus minus 3 digits from the mean. But then again, when I put the same sample back in, I get a different reading every time. So But the ones that, the three first ones were very similar in the cup. Manual roasting is actually where we have the biggest challenges. And due to that is, if you look at when you're manually roasting, you're having what I would call a open loop control system. That means that you're adding a fixed amount of gas, but you're not reading any of the values that's from that point on. So in order to have a closed system, you have to be the one that is actually paying attention to what is happening and adjusting the temperature and airflow accordingly. But humans are humans, and we don't pay as much attention as a small microchip could do. So what we'll experience is basically that the most even roast we have when we're doing automatic roasting. So this is a profile from an automatic roast. So you see, and this is, mind you, we haven't really fine-tuned the machine quite yet. We're still working on fine-tuning it. We're still working on getting the maximum out of our temperature sensors, which is absolutely critical for this type of application. But what you'll see is that we're trying to follow the green line, and the blue line is what we have measured. And then you have the gas percentage that is going up and down accordingly, trying to compensate for the error, as we would like to say. So the difference between an automatic system and a manual system is automatic system works as a closed loop feedback system. So you're setting up a set temperature, and of course you're getting an error back, which is the temperature reading itself. And this error compensates for it. And this error in the temperature reading is basically what's the difference between a manual roasting and an automatic roasting. And that is what closes the loops and makes it, I mean, as you probably all know, that if you have a very different temperature in the room you're roasting in, and you're roasting manually, you will have a different temperature in the roasting chamber as well. It might not be a significant difference, but there will be a difference. But this difference is even larger in a small-scale roaster. Luckily for us, we have a preheating stage where we preheat the air before it enters the roasting chamber, and all the air that goes through the roasting chamber goes through the gas burner. Right here we had first crack at 4 minutes and 43 seconds with a deviation of 4 seconds. But what's more interesting, because of course I can just say that first crack happens at this time. What's more interesting is seeing the time corresponding with the bean temperature here. And here we have a bean temperature at first crack at 184.1 with a deviation of plus minus 0.3 degrees. And bear in mind, this is two different machines. So on the left side you have sample roast number 1, and on the right side you have opposite. Anyways, there are two different machines separated on the left and right here. And this is the first and second roast after 10 minutes heat up. So that was all.
Thank you, Sverre. I finally learned your names now. Trond is blonde, and Sverre, I don't have any relation to that, but at least I remember the blonde. So if you can take a seat in the sofa and relax, we still have time for some Q&A. Yeah. I just want to start the question round with one thing, and because I kind of know the answer, but not the whole thing. You spent 4 years already developing this and made many prototypes. There's a reason why these products have to cost money, I guess. Can you give a little insight to, how important it has been to get funding and how you've actually done it, and how much you actually have needed to do this for 4 years?
Should I answer? Yeah. Well, when Sverre made his first prototype, I'm then the business side of Røst, and Sverre is the engineer and designer and electrician and everything else. So I'm the business side and his assistant. Do a lot of assistant work. But First off, we received a grant from Innovation Norway over a 2 years period, and that was around 700,000 NOK. But we didn't have any salary, and it was all into parts. So everything, all the money we spent on buying parts and producing the prototypes. But once we were done with those first 700,000, because that's what you get. You can get 700,000, but then you have to actually get some external funding. And at that time we had prototype 4, which looked not so very sleek.
That's the
and
one
nice.
with the vacuum motor.
I think we scared a lot of people with that vacuum engine. Anyways, so that was what I had. I had prototype 3, pictures from prototype 3. We had results from some copying, and we had our minds of where we were going. And then we started trying to get money. And I think I spent 1 year totally unsuccessful. It was so hard to find the money. But the instant Sverre made the drawings and we produced prototype 5, everything changed. Once you had the mechanical parts, and especially I think the design ready, and we had the screen and we could interact with the coffee, then everything changed. We became like this cool little startup, and we received quite a lot of money from Innovation Norway and Angel Challenge. So that's what can drive us now, because now we cannot work this as a part-time job anymore. We have to go full in, and it's not just a normal job. It's weekends and vacations. We have had 1 week vacation this year, building a cabin for our dad. So it takes a lot of time, and we need some salary as well to cover our living expenses.
One big difference between the previous prototypes and for up to prototype number 4, what we did was we bought off-the-shelf parts and we combined them. So it didn't work flawless, but we managed to make it work as a minimum viable product, as a concept test. But at some point you just have to sort of take it up the next level. And that means developing your own electronics. It means that you have some guy that's that's developing it, and then you have somebody that has to test it and make sure that it's safe, which is also quite an expensive thing to do. So you have from this stage where you go from having just a prototype and verifying that it works as a concept to making something that people can actually use and feel safe. There is a huge gap in the cost of actually producing the parts. Because now we can't just buy off-the-shelf parts, we have to develop them ourselves. So we have someone working full-time, almost developing the electronics and combining all the features that we want into something that will be custom made for just our machine. And as well, once you start going from just having something that it works, but it's not, and it's not critical that you got this part from eBay and you don't really know what's in it, to the point where you have to have documentations of every chemical component in every part of your machine. As part of the EU regulations, you need to make sure that not a single part in your machine contains anything that is forbidden in the European Union. That means that you can't anymore just go on eBay and just buy this part because it looks great and it fits in my machine. You have to actually source it, and you have to make sure that the documentation is right. So you receive this documentation, for instance, for a motor, and half of it is Chinese. So then you have somebody to translate it, and you have to take this and make it, you have to take this document, which is basically a test report. And it gives you all these different standards that it's testing for. But then you show it to the people here in Norway that it is gonna verify that it's correct. And they come with a red pen and just cross everything out. It's like, that's not the standard, that's not the correct standard. And they wanna do their own tests. And then they have, quite high price for just making sure that something that in it seems like a very trivial little thing. You just wanted a motor, and then it comes with all the paper and all the things around it, which makes it so much more expensive.
We had a meeting with them. We had to pay 400 euros before we showed up for a half an hour meeting. So it's quite expensive. Another thing I would highlight is that if Sverre was just a designer, if he made the first design, which looked like prototype 6, and we were to find an engineer and then engineer everything which is inside of that box, then we would never be able to get that kind of money. Because the engineering part, the electronic part is now very expensive, but the engineering part is super expensive. And it's taken 7 years experience to finally getting all the bits and parts. And that's what we're working on now. Not the design, the external design, just how we assemble the parts inside so that it's durable and it's Røst good coffee.
Anyone want to ask any questions? If you compare it to a big roaster, like the burner system and everything, what's the kind of most similar setup? Like drum roasters or fluid bed roasters? Or
This is well, our patent pending solution, of course, is a combination of a drum and a fluid bed roaster. So what we have is we have mechanical agitation of the coffee beans. So you can adjust the airflow however you like, and it won't affect how the coffee beans are moving around. But the primary heat source is through the hot air that is entering, and the hot air is entering through the drum wall itself and not the side walls. So that's why it's moving diagonally across the roasting chamber. So I would say that if you were to sort of compare the system, it's more similar to, for instance, a lowering than a traditional probat, because we don't heat up the drum. The drum itself is only 1 millimeter thick.
Great. Any other people want to ask something? No? Nothing? Yes.
So eventually, would the gas be plumbed into a main line or run off a bottle?
We're running it out of we did some calculations on it, and we can roast approximately, what did I figure out? 600 batches on 5 kilos of propane. So basically, it doesn't use so much energy, and also because it's automated, it turns down when you're not roasting. It just shuts down the gas usage. And also it requires only 30 millibar of gas pressure. So that's like a standard household unit. When we were dragging it around having small presentations, we were roasting on a 250 gram canister.
And I mean, you've already been to at least one exhibition down in Budapest, was it?
Yeah.
How has the reception been, and what's the feedback on the prototype? Because I think you were able to demonstrate it down there.
Yeah, first time we showed a machine, and first time we roasted on this prototype was 2 weeks before I went to Budapest. So it was quite nerve-wracking standing there and assembling the machine first time at a stand in front of so many people, turning it on, just hoping that nothing has gone wrong during the flight. But we had an amazing reception there, as I think it was 2 hours after launching the product, we won Best New Product of the Year award in the technology. And from that point on, there was just a constant queue outside, and we were with the Nordic approach and Third Wave Coffee.
Third Wave Coffee Source.
Third Wave Coffee Source, yeah. So they always gather a lot of people around the stand. So there were always a queue, and we were standing and roasting. It was a lot of fun, and basically the feedback we got was that they loved the concept, they loved the design. But at that time, we were only roasting manually because we hadn't fine-tuned the algorithm that's gonna take the automatic part. So that's like one of the feedback we got was when you make it automatic, then it's a home run.
Yeah, I can add that I think we've had a way better reception than we expected. We haven't done much sales so far, but still the next production batch is sold out, just based on Instagram and possibility to do a reservation on our webpage. So we're looking forward to the next year where we actually will have better machines, and we will go out and demonstrate at more coffee fairs, and especially packing a car and just driving around, showing the potential customers and getting feedback, because we will always need feedback. And we now have 4 pilot customers giving us good feedback, and that's very valuable. And in a couple of months, all the electronics will be done, and it will be.
And one of the key elements as well is that the machine is Wi-Fi based. So the machine itself it doesn't need Wi-Fi or anything, but it roasts everything you do is recorded. Next time it's logged to Wi-Fi, all the data from all your roasts and everything is then stored in your cloud, so you can access it from any web page just using your domain. But what's important is that since the machine is Wi-Fi based, we can sell the machine as it is. And once we're doing modifications to it, when we're fine-tuning the algorithm, when we're adding features, just changing how the screen layout are, there are so many things that we can keep working on. And what's great is that with a single push of a single button, we will update every machine that has ever been sold. So you will when you buy the Røst, you will always have the latest updated version of the software.
Yeah, and we have just like Tesla, we have functionality in the first roasters, which will be activated at a later stage that we think will be very, very interesting.
I have a question regarding the logging system. Is there any possibility to not only use your own database, but most of us we use also other logging systems which are very helpful? Is there any?
That's a very good question, and we are definitely interested in cooperation with, for instance, Cropster. We have been in dialogue with them, but we haven't taken it any further right now because we're so much to do. But what we want to do is make the machine so that right now, like live view and everything is activated automatically when you just log into your domain. And also when you're adding the coffee beans, the sensor registers it and starts the logging process and everything for you, so you don't have to do anything there. But what we are doing is we're saving all the data, and what we hopefully will be able to achieve is to have some sort of collaboration with someone where we can basically give them the feedback from our cloud system to their cloud system, so that you can access the data through a different service.
It's just data points, so should be.
Yeah, it's just data, so it's quite easy to make.
It's easier than to connect your roaster to a hub and do those things.
We also have USB on the machine just to make sure if somebody's like roasting in a basement with no access to Wi-Fi, you can just plug it in with USB.
Yeah, I have the mic. Which data are you using or saving when you
right now,
fully automatic roasts?
We're logging all the sensors. So we're logging the bean temperature, environmental temperature, the gas value, the fan value, the time, every event like first crack, also the speed of the roast cool down process of the coffee beans will be logged. So it says how long your the cool down period was. Bear in mind the cool down is in a separate container, so you can back-to-back roast. You don't have to cool the coffee beans in the roasting chamber.
Hi, congratulations. Super inspiring and super impressed with how you guys are working on what you're doing. You said the next order is already sold out. So what's the timeline? When can we get one?
Timeline was October, but it was also July and April. We are aiming for starting production in early January, and the only thing which we do not have control over is that we have to send one machine to Germany for a gas test. We use a German-built gas valve, so we don't see any problems, but we don't really know how long it take. But we're aiming for January, and the only thing, we have small production batches now, and that's just because we need to figure out, okay, so this screw on the inside here, does that make any problems for us when we're assembling it? Assembling is the biggest cost in Norway. So we need to do all those small adjustments. But hopefully Sverre will be able to do them quick, and we'll have a good agreement with our production facilities so that they can also be a little bit quick. And then hopefully we'll start the next production a couple of weeks after the first, and then just continue. And
So one of the important things for us is that this is a problem with engineers. They always want to perfect their product before they sell it, and to some degree we are doing that. But what's most importantly is the mechanical part functions. So then we can update the software after the machine is sold. So that can save us some time in the development time or the production time of the next batch.
Yeah. Yeah.
Maybe it's too soon to do this question, but when you are doing so beautiful work, are you planning to do it bigger in a bigger machine?
Yeah. We have some plans. We haven't left the consumer market either, but we're focusing on the sample roaster. We'll perfection that one, and we have some ideas for how we can do a little bit bigger roaster as well.
Yeah. So one of the key features of our design is that it's scalable. That's part of the reason how we ended up with what we ended up with. Also the fact that you can read a bean temperature of 100 grams pretty precisely.
Okay, 2 very quick questions because we need to move on.
I was just interested because it looks quite compact, and
Yeah.
you said it was a bit hard to assemble the machine. How is it to maintenance and clean? Is it easy to kind of get in there and clean the drum?
Cleaning is definitely a really important subject. So right now, all you have to do is remove 4 screws, and you have access to the internal side of the drum roaster. So what you can do is you can clean out the entire ventilation system and the roasting chamber simply by taking off 4 screws. The ventilation system, the fan itself, can be cleaned and accessed from the back, but during maintenance you can also remove both fans and do a thorough cleaning of the inside even of the shaft separator system. So cleaning is definitely very important. One of the very nice features of having a fixed drum is that the coffee beans are constantly cleaning the parts where the coffee beans are in contact. So if you look through the window of one of the machines, I think this machine has probably roasted about over 100 kilos of coffee in the last 2 months. And what you can see is polished stainless steel.
Yeah, besides one plastic piece, because
You put it in.
there was a plastic piece in one of our samples, so it's stuck to the window.
Yeah, so do you have flexibility in batch size?
We can roast as low as you want. The biggest problem then is that you have to learn how to roast on it. Because if you put 50 grams in it, the bean temperature is placed in such a way that it's ideal for 100 grams. But if you do environmental roast based on the environmental roasting temperature, you can just define a profile and you can have a very good roast even on 50 grams. Funny thing about that is that you can roast coffee in less than 2 minutes.
Here you go, guys. Thank you so much. If you